Alkali metals are paramagnetic, but their salts are diamagnetic. Explain. Alkali metals contain one unpaired electron Ns1 and hence are paramagnetic. However, during salt formation, this unpaired electron is transferred to the non-metallic atom forming its anion. As a result, salt has paired electron both in the cation as well as in the anion, and hence alkali metal salts are dimagnetic in nature. Which out of sodium or potassium has higher melting point? On going from Na to K, the size of the atom increases and hence the metallic bonding weakens. In other words, sodium has higher melting point than potassium because of stronger metallic bonding. Among alkali metals in aqueous solution, Li plus ion has the lowest mobility. Why? Because of the small size among alkali metals, Li plus ions are most highly hydrated in aqueous solution. As a result, among alkali metals, mass of hydrated lithium ion is the highest and thus the lowest ionic mobility. Next, why alkali metals impart color to the flame? Alkali metals have low ionization enthalpies. Their valence electron easily absorb energy from the flame and are excited to higher energy levels. When these excited electrons return to the ground state, the absorbed energy is emitted in form of light. Next, lithium has highest ionization enthalpy in group 1 elements, yet it is the strongest reducing agent. Why? In aqueous solution, the tendency of an element to lose electrons does not entirely depend upon its ionization enthalpy. It also depends upon its enthalpy of sublimation and the enthalpy of hydration of the ion left after the loss of an electron. The combined effect of these factors is measured in terms of electrode potential. Since lithium has the most negative minus 3.04 volt electrode potential of group 1 element, therefore lithium is the strongest reducing agent. Next, sodium fire in the laboratory should not be extinguished by pouring water. Why? The reaction of sodium with H2O is so exothermic that the H2 produced catches fire. 2Na plus 2H2 arrow 2NaOH plus H2. As a result, the fire spreads rather than being extinguished. Therefore, H2O should not be used for extinguishing sodium fire. Instead, pyrene CCl4 should be used. When CCl4 is sprinkled over fire, it being volatile, boiling point 350 Kelvin, immediately forms vapors. These vapors, being non-inflammable and heavy, surround the fire. As a result, supply of air is cut off and the fire gets extinguished. Why is it that on being heated in excess supply of air, K, Rb and Cs form superoxide in preference to oxides and peroxides? K plus, Rb plus and Cs plus are large cations and superoxide ion O2 negative is larger than oxide O2 negative and peroxide O2 2 negative ions. Since due to higher lattice energy, a large cation stabilizes a large anion. Therefore, these metals form superoxides in preference to oxides and peroxides. Why superoxides of alkali metals are paramagnetic while normal oxides are dimagnetic? Superoxides contain the ion O2 negative, which has the structure this one, containing a 3 electron bond. That is, it has one unpaired electron and hence is paramagnetic. Normal oxides contains the ion this one 2 negative, do not have any unpaired electrons and hence are dimagnetic. Next, why Alkali metals are normally kept in kerosene oil. This is because in the air they are easily oxidized to oxides, which may dissolve in the moisture of the air to form hydroxides, or they also combine directly with water vapors present in moisture to form hydroxides. The hydroxides in turn may combine with carbon dioxide of the atmosphere to form carbonates. 4m plus O2 arrow 2m2o, m2o plus H2 arrow 2MOH, 2MOH plus CO2 arrow M2CO3 plus H2O. Therefore, to protect them from air and moisture, they are kept under kerosene oil. What makes lithium to show properties uncommon to the rest of the alkali metals? The unusual properties of lithium as compared to other alkali metal is due to the exceptionally small size of atom and ion. Second, high polarizing power, charge by size ratio. Third, high ionization enthalpy. And fourth, absence of d orbitals. Next, when is a cation highly polarizing? Which alkali metal cation has the highest polarizing power? A cation is highly polarizing if its charge by size ratio is very high. Because of its small size, Li plus ion has the highest polarizing power among the alkali metal ions. Why does table salt get wet in rainy season? Pure NaCl is not hygroscopic, but table salt is impure NaCl containing impurities of Mg2SO4, CaSO4, MgCl2 and CaCl2. All these being hygroscopic absorb moisture from air in rainy season. As a result, table salt get wet. Thank you.